Hi friends, welcome back to the channel. Today we are going to look at LeetCode problem number 100, same tree. So given the roots of two binary trees P and Q, write a function to check if they are the same or not. Two binary trees are considered the same if they are structurally identical and the nodes have the same value. So as you can see in this example, one, like all the nodes are structurally identical and they have the same value. So one in the root, here also one in the root, two as a left child of the root, two as a left child of this root, three as a right child, and three as a right child. So we are going to return true. So I also took a similar example here to explain how we can check if the both trees are same tree or not. So in this tree we have 7 nodes, 1, 2, 3, 4, 5, 6, 7. So as you can see, these are structurally identical, and all the nodes on related levels, they follow the structurally sameness, and correct matching values. So they are the same tree. So how we are going to find if these both trees are same or not? So what we can do is we can actually use a breadth first traversal and a queue actually, and we can traverse both the trees simultaneously, and we can put the um, node values like nodes into the queue, and we can compare those nodes one by one. So let me just take a sample queue here. So let's say this is the queue that we have. So we will be actually having a function where we will pass two nodes and we will compare those two nodes in the queue. So for example, first we will pass this one and this one into the queue. So the queue will have one as two nodes, and um, it will call out the first node and second node, both nodes it will call, and it will actually compare the values. So it will find that both are having a same value. So it adds its left child and then its right child. So first we will add a left child of the tree, which is 2 here and 2 here for the second tree. So we will add a 2 as a left child of first tree and 2 as a left child in the second tree. And we will add 3 as a 3 as a right child of the first tree's root, and 3 as a right child of the second tree's root. So our queue will consist of 2, 2 and 3, 3 nodes here. So once we add it, we will again when we are processing that level of the tree, then we will pull the elements from the queue. So we get 2 and again 2. So both we will compare. So both matches. Then we will. So when we are comparing and when they are matching at the same time, we will keep adding their left and right child. So at the same time, we will keep adding the left and right child. So we will add here 4 and 4, because 4 is from the first tree and 4 is from the second tree, and 5 is from the first tree and 5 is from the second tree. We will add into the queue. So we added 4, 4 and 5, 5 here. And after that, we will call the other remaining element, which is 3 and 3, right? So we will compare both the elements. They are matching. So we will again add their left child and their right child into the queue. So same here. So 6, 6, 6 and 7, 7 we will add into the queue. So 6, 6, 7, 7. And then we keep, so this is the last level to process. So we will keep polling the elements polling the nodes in pairs and keep comparing them. So we will poll 4, 4. So both are matching. So we will continue. We will poll the next two 5, 5. So both are matching. So we will continue. 6, 6 also matching and 7, 7 also matching. So at the end, all the elements are structurally compared and have been matched. So we will return true. And these, so which means that both these trees are same tree. So the same approach that we have discussed, I will show you the code. So in the is same tree, I am just calling a check same tree function where I am calling a two tree nodes. That first thing we will pass is the P and Q nodes, which are the roots of both trees, right? A is the root of first tree and B is the root of second tree. And we are going to use a queue of tree nodes. And we first thing we will do is we will offer the roots of both trees to the queue first, and then we will do a while loop, which is, it will keep polling the nodes in pair. So first it will poll like N1 and N2, and it will first check if both nodes are null, then we are good. Then we can just continue. We don't have to do anything in that case. But if one of the node is null and the other is not null, then we know that the both tree cannot be same. So we'll just return false here. If that is not the case, then we will make sure that the both nodes values are matching. If they don't match, then they cannot be same tree. So we'll return false here. And after that, we will, we will add the left node of both the nodes and the right node of both the nodes for processing into the queue, right? So as we were discussing here, we will add like both nodes, left node, and then right node of the node. So at the end, if the loop processes, then it means that it has structurally matched all the nodes in the tree, and we will return true here. So I took the one example that I explained here. So these are the two trees we are passing. So both are matching, so it will return true. And I passed negative test case where we have two trees which are not matching. So let's run this thing and make sure that it works. Yeah, so we got true for the first one and false for the second one. So it's running correctly. So let's submit the code. So we got 100% on the runtime and 7% better on the memory side. So so simply using the queue and breadth first traversal, we can check if both trees are same or not. If you like this video, please share this video and subscribe to my channel and click on the like button. Thank you.